Pre-calculus. Today we're covering all of the notes for lesson 2.6, which corresponds to lesson 1.7 in your textbook. We're going to just be finding compositions of functions. The composition of a function looks like this. So it is read f of g of x, or f composed with g. And when I see this notation, I simply write f of g of x, which means, now you're up here, you're plugging x plus 1 in for x right there, and so you're squaring it. In class, we would finish that off by FOILing. Here's the formal definition of composites. Your classmates wrote, they did not write the previous slide, they wrote all of this instead. And then we did some examples. So here's all of the work that we have for our first example. We did f composed with g, so that means g of x goes in for x. So for our first example, we put 4 minus x squared in right here for x, and you can see that right there. And then on the second part, we put f inside of g, so we found g of x plus 2, and we multiplied that out and cleaned it up. And then we found the answer to b evaluated at -2. So we basically just took -2 and plugged it in here and found 4. Now the other way to do this problem would be to take g of f of -2, and if I plug -2 in here, I would get 0, so g of 0. Now I take 0 and I plug it in there, and I would get 4. So that's the other way to get the answer of 4. And then on d, I plug g inside of itself. So wherever I saw x, I put in 4 minus x squared. So that is d, and then it's FOILed out, etc. For this one, we're going to be looking at domain as well. We did talk up here that domain was not an issue with this first example because the domain of each function, so the domain of this one was also all reals. In fact, all polynomials have a domain of all reals. And when I do composites with real numbers, I get real numbers back. But here, we do need to talk about domain. The domain of f is all reals, but the domain of g has an implied domain that x can't be -1. For f composed with g of x, we put 3 over x plus 1 in for x, and then we got a common denominator and we simplified it. And there's its domain right there. Then we went backwards and we put this in for x right here, and we cleaned it up, and there's its domain right there. Finally, we did a word problem. Okay, capital N is the number of bacteria given by this function. T is the temperature in Celsius. It ranges from 2 to 14 degrees Celsius. So you have bacteria in food when it's refrigerated, and then this function here gives you the temperature of the food as a function of time. And that time is from 0 to 3 hours. So when you find their composite, and that's all of the work here in green, this is what you get. And that basically just gives you the number of bacteria in terms of time t. If you are given then 2,000 bacteria and you want to know at what point it reaches that and you're solving for time, you would then set your expression from A equal to 2,000 and you would solve for the number of hours. All right, hope to see you guys back tomorrow.